Hi everyone, this is Rachel Cassidy with the State Division of Drinking Water. I am here to present to you the radionuclide rule for public water systems in Utah. So to start off with, let's talk about how to get a hold of me in case you have questions as we go through this presentation. My name is Rachel Cassidy again. My contact phone number is 801-536-4467 and my email address is rcassidy, C-A-S-S-A-D-Y, at utah.gov. So before we talk about the sampling requirements and what to expect for that, let's talk a little bit about what are radionuclides. Radionuclides are just atoms that are decaying. They're taking parts of themselves and they're chucking them at their neighbors. So I like to think of it as the kid in the neighborhood that's throwing pieces of like bricks through your front window, except it would be more like a zombie because they're throwing pieces of themselves. So maybe like they rip off their hand or something and chuck it at your front window. But either way, they're particles that are throwing pieces of themselves at their neighbors, and it's damaging. It hurts the neighbors and it causes problems. So this radioactive atom, let's say it's emitting like an alpha particle. An alpha particle is 2 protons and 2 neutrons. It's pretty heavy, high energy particle. It's got a positive charge of +2 from the 2 protons, and it's not exactly everybody's best friend. So that's an example of an alpha emitter. Now, NOVA has put together a really helpful presentation on radionuclide sampling in drinking water. We're going to go through that. It's just a quick 2-minute presentation that will start.
Radionuclide testing. The radionuclides test, or you may have heard it called radio for short, is a test required by the EPA on drinking water. So what are radionuclides, and why do we test for them in drinking water? A nuclide is a general term applicable to all atomic forms of an element. A radionuclide is an unstable form of a nuclide. They may occur naturally, but can also be artificially produced. Most drinking water sources have very low levels of radioactive contaminants called radionuclides. Most are naturally occurring, although contamination of drinking water sources from human-made nuclear materials can also occur. Of the small percentage of drinking water systems with radioactive contaminant levels high enough to be of concern, most of the radioactivity is naturally occurring. Certain rock types have naturally occurring radioactive elements. Most radioactive contaminants are at levels that are low enough to not be considered a public health concern. At higher levels, long-term exposure to radionuclides in drinking water may cause cancer. In addition, exposure to uranium in drinking water may cause toxic effects to the kidneys. The radionuclides that are regulated by the EPA and included in the radio tests performed by NOVA are combined radium-226 and 228, adjusted gross alpha, beta particle and photon radioactivity, and uranium. All occur naturally in some drinking water sources, with the exception of beta particles and photon radioactivity, which may occur due to contamination from facilities using or producing radioactive materials. To learn more about radionuclides in drinking water, or to have your water tested for radionuclides, contact NOVA today. NOVA's team of scientists are always available to discuss sample collection, testing, or your test results should you have any questions or concerns about your drinking water.
So there you go. That was just a short primer on radionuclide sampling in drinking water, where it comes from. The radionuclide rule requires testing of these types of emitters and then 3 heavy metals. So the first 2 are types of emitters. So gross alpha is any particle or any atom that's emitting alpha particles. Gross beta is any atom that's emitting beta particles. Radium-228 and 226 are decaying forms of radium. Radium is just a heavy metal naturally occurring in the ground. And then, of course, uranium naturally occurring as well. Radium-226 is primarily an alpha emitter, and radium-228 is primarily a beta emitter. I don't know if you care about that or not, but now you know. So here's a picture of radium. Radium oxidizes when it's in contact with the air. It turns black, but it's kind of silvery, and it's just naturally occurring. And we do have quite a few detections for radium-228 in drinking water in the state of Utah. It's fairly common. So who is supposed to sample for radionuclides? Well, it's all community water systems. So what is a community water system? Well, it's a public water system that's serving year-round residents. So it has 25 or more people or 15 or more service connections, and these people are living there year-round. So they're cooking with this water, they're washing their clothes with it, they're bathing, showering, brushing teeth, doing laundry, making bottles. They live there year-round. So our concern is short-term and long-term health effects when we consider the sampling for this type of a water system. So, community systems. So your community system, then you know you have to sample for rads. So the biggest question is, when am I supposed to sample for radionuclides? Because it's a little bit tricky. So it starts off for all new sources as quarterly for 1 year of operation. So if that source is only used for a couple of months out of the year, then we have to take that in consideration when we evaluate when they should be taking a sample. So if the source is operational year-round, then I need 4 samples for each calendar quarter. After those 4 samples are the results hit our office, then we look at the data and the results determine whether or not that source will then reduce to either once every 3 years, once every 6 years, or once every 9 years in the sampling. So let's talk about the quarterly sampling really quick. This is where it gets pretty tricky for some people, and this is where we get the most notices of violation. So these are the calendar quarters. They never change. They're always the same. The first quarter of the year is always January, February, March. Second quarter is April, May, June. Third quarter is July, August, September. And fourth quarter is October, November, and December. So something to keep in mind when you're sampling for radionuclides is that it takes the laboratory minimum 3 weeks, more around 6 to 8 weeks to get the results back to you, and for you to get the results to me can take another day or so. So it takes some time. Therefore, it is a very bad idea to sample in the last months of the quarter. So see March, June, September, and December. If you sample for rads during those months, I'm not going to get the results from a March sample until about the end of May, beginning of June, which you would think, well, what's the problem? Well, let me tell you the problem. The problem is I'm required to send out notices of violation and check for violations the beginning of January, May, August, and November. So if you sample in March, I run violations in May, I don't see any results for your source, I send you a notice of violation. You come back to me and say, look, here's a copy of my chain of custody. I took the sample, we just don't have the results back yet. Then I have to go back and delete the violation. I send you a retraction letter. I say, I'm sorry. Please don't hate me. It just causes a lot of problems. So when you're doing quarterly sampling, it's always in your best interest to avoid sampling during this last month of the quarter. So try to take your samples, if at all possible, during the beginning of the quarter, so January, April, July, October. I do understand that life happens and that can't always be the schedule that you make it. Sometimes it has to be in March, June, September, December. That's fine. One thing to keep in mind with your sampling is that compliance is based on the date the sample is taken. So if you take the sample January 10th of the year and I don't get results until April, that sample does not count for quarter 2 because that's when I received the results. That sample counts for quarter 1 because that's when the sample was actually taken. So keep that in mind as well. Compliance is based on the date the sample is taken. Okay. So you're off quarterly sampling. You did your 4 quarters. Now you want to know when you're supposed to sample every 3, 6, or 9 years. Well, these are the set EPA cycles and periods that we use for the 3, 6, and 9 year sampling for rads. So Currently, we are in the third cycle, the second period of the third cycle. So, if you last took your every 3 year rad sample in 2011, then you satisfied this 2011 to 2013 first period, and your next sample is due anytime between January 1st and December of 2014 and December 31st, 2016. The next third year sample should be taken anywhere from January 1st, 2017 to December 31st, 2019. The 9 year cycles, the first one began January 1st, 2002. The 9 year cycle that we're currently in started January 1st, 2011. So if you're once every 9 years and you last sampled in 2010, that next 9 year sample is due by the end of 2019. The every 6 year periods start on these 3 year blips. So most of them start 2011. There's a few that start 2014. Check your monitoring schedule if you have any questions about what period your sample is due in. So, like I said, check your monitoring schedule. This is me politely telling you to please check your monitoring schedule, except I'm not a dude. And so your question to me is, how in the world do I check my monitoring schedule? Well, this is how you do it. You go to our website, which is, the URL is right here. It's drinkingwater.utah.gov. And I've circled the link you want to click. You want to click Online Reports, and then that takes you through a process wherein you can pull down your monitoring schedule, your IPS report, your bacteria summary, those important reports about your water system. You can access this anytime. You can pull it up, once a week if you want to. You can do it once a month. I definitely recommend you do it on a regular basis. If you have quarterly sampling requirements, if I were you, I would pull this up at least once a quarter to make sure that it reflects the samples that you have paid for and gone to the effort of taking. Okay, so you pulled up your monitoring schedule. What are you supposed to look for? What does it look like on your monitoring schedule? Well, it looks like this. This source has inorganics and metals, nitrate, pesticides, RADs here, radionuclides. Sometimes we call it RADs, sometimes we call it radionuclides. It's just RADs is just the easy way of saying it. Sodium sulfate TDS, and this is VOCs, volatile organics. So radionuclides, one routine sample due every 3 years for this source. The last sample that the source was taken was sampled on June 26, 2013, and so then you want to look at the next sample due date. Don't look at the years on this. This is wrong. I'm just having a glitch with the monitoring schedules at the time of this presentation. But the due dates, the next sample due dates here should say 1/1/2014 to 12/31/2016. Anyway, look at these next sample due dates. They will be correct. They're not correct here, but they will be correct when we provide them to you. Okay, that's your monitoring schedule. You took your samples, you contacted you have to use a certified laboratory. If you have questions on which certified laboratories, again, on our website, we have a list of certified labs, but you want to contact a certified lab that can either do the sample for you or ship it out to a laboratory that is certified. And you get a copy of your results back. So this is a copy of an actual sample result from Chemtech Ford. This is what I'm looking for when I look at this. I want the gross alpha result, not the variance or the LLD. I want just gross alpha. And the result here is 2.5. Over here it shows that the maximum contaminant level, or MCL for short, is 15. So 2.5 is less than 15, so that's good news. And then check your units. The units for gross alpha and radium-226 and 228 are always picocuries per liter. So there's your result for gross alpha, and in order to have a complete rad sample, I need to see results for gross alpha and radium-228. So here's your result for radium-228, 0.4. The maximum contaminant level is 5, so you win. You've met the MCLs, you've taken the sample, the units are right, the results look great. Something to note here is that if the gross alpha result is greater than 5, then the laboratory is required to test for radium-226. So if this number were like 6.2, then I would expect to see a radium-226 result here as well. That's something you can double check with your laboratory. Okay, so quarterly sampling. This is where we have a lot of confusion and quite a lot of problems. So if the source is used year round, this is very basic and easy. This operator took the first quarter sample in the first quarter, second quarter in the second quarter, the third in July, and the fourth at the very end. This is perfect. After this quarterly sampling, I would average the results, and then I would determine what frequency this source should be at, either once every 3, 6, or 9 years. Apply that and then send you an updated monitoring schedule. What if the source is only used seasonally? We have a lot of sources in Utah that are used just during the summertime. This source is used between April 1st and September 30th. So all I need is a second quarter sample and a third quarter sample. So this operator took a sample during the second quarter, April 20th, and the third quarter, which is July through September. So this August sample is perfect. That satisfies the quarterly requirement because it's quarterly for 1 year of operation. And for this source, 1 year is just this 6-month period. So if you have a seasonal source, make sure that I know it's seasonal when we start the radionuclide sampling. It's very important. So, and something else to note, never turn on your source just to take a radionuclide sample. If your source is down for a quarter, just let me know, give me a heads up so I won't apply a violation for that quarterly period. But then if the source is operational for that quarter, the following year we can fill that bucket then. So this is an example of something like that happening. Here's a source that's used year round. The operator took the initial radionuclide sample in February. Let's say the source went down for the second quarter of the year. So the operator let me know. They sent me an email or called me on the phone and told me that this source was not used between April 1st and June 30th, so there was no way that they could get the quarterly rad sample taken. So I said, okay, that's fine. No violation will go out. Just take it in the third and the fourth quarter. So the operator took it in the third quarter, but then something happened, life happened, budgets happen, people forget, and the sample wasn't taken during the fourth quarter. So that's a notice of violation, but it's really easy to get rid of a notice of violation. All you do is you have to take the sample again when it's next due, and those current results will make it so that I can delete that violation. So the operator the following year then took the second quarter sample and the fourth quarter sample. Now, something to note is that when I'm looking at your quarterly samples, I am filling a bucket for each calendar quarter. So if this operator had taken in 2014 a sample in March, that would have been a huge waste of money because I already have a first quarter sample. I don't need another one. I need a second quarter and a fourth quarter. So make sure that you know which quarters have been fulfilled and which quarters you do need to fulfill. And the best way to do that, the only way to do that, is to get in contact with me, and I will get it to you in writing over email, or we'll talk about it on the phone. But we just have to fulfill, and it can be in separate years like this source here. It doesn't have to be consecutive because things happen, but let's make sure we fulfill that requirement as best we can, as fast as possible. So, quarterly, again, make sure you stick with your quarters. And now you're done with quarterly sampling. What are you supposed to do now? Well, the first thing, you don't have to do anything. Now it's all up to me, but it's helpful if you know this too, because then you can always double check me. I'm not perfect. I make plenty of mistakes all day long. Well, hopefully not all day long, but I make mistakes. So the more you know, the easier it is for you to understand why the monitoring schedule is set the way it is. And then it's also great if you can double check me. You need to know the maximum contaminant levels. The maximum level for alpha emitters is 15 picocuries per liter. Radium-228 and radium-226 is 5 picocuries per liter. And uranium is 30 parts per billion, which is the same as micrograms per liter. So what I do is I take the average of your results and I compare it against the MCL. So if your average results are greater than half of the MCL for alpha and radium-228, but they're less than the MCL, then that source should be on once every 3-year sampling for RADs. So the MCL for alpha is 15. Half of that is 7.5. So if your average result is 8.1 from your quarterly sampling, then you should be at once every 3-year sampling. Even if your radium-228 is non-detect, I have to take the most strict sampling frequency and apply that. And the most strict is the one for the gross alpha, which is the once every 3, if that average is 8.1, like I said. So if it's less than half of the MCL, so less than 7.5 for alpha emitters or less than 2.5 for radium-228, but it is detectable, then the frequency that source should be on for sampling RADs is once every 6 years. If the average results are non-detect, then the frequency should be once every 9 years. So here's an example. Here's the quarterly results for gross alpha for a source and the quarterly results for radium-228. You take the average of those, and I get 7.8, which is greater than half of the MCL, but less than the MCL. So it should be, this tells me once every 3 years. The average for the radium-228 is 0.35, which is technically non-detect because the detection level is typically about 1 or less. So I would look at this and I would say, this is probably once every 9 years. But this is once every 3, so I have to take the most strict one and apply that. So once every 3 years. So the reduced frequency for this source is now the radionuclide samples are due once every 3 years. So feel free to double check your data. Call me on the phone. We'll go over it together and we'll make sure that you're on the right reduced sampling for your source. Okay, so what happens if your results are over the MCL? Let's go into some gory details. Let's say you got an alpha result that was 20 picocuries per liter. So what you would do is you would get a letter from me asking you, requiring you to sample for RADs for an entire quarter. And what I need is I need results for everything. I need uranium, radium-226, radium-228, and gross alpha. The uranium is very important because what I can do with that uranium is I convert the uranium to picocuries per liter and I subtract that from the gross alpha result. That gives me an adjusted alpha result. And then I compare that adjusted alpha to the MCL. So that helps you out quite a bit. You want to make sure you get those radium results. So after a year of sampling for all of those 4 RADs for 1 year, I take the averages and I compare against the MCL. So here's an example. This is a real source. They had a gross alpha result in January of 2011 of 22. MCL is 15. So I sent them a letter and they went on quarterly sampling. That included the uranium as well as the radium-226 and 228. So you look at the radium-226, all vary below 5, same, or 228, same, oh, this should be labeled 228. Sorry about that. This is the 226, 228. Numbers are great, below 5. Here's the alpha and here's the uranium. So what I do is I take this uranium number, I convert it to picocuries per liter, and I subtract it from the 7.9, which gives me an adjusted alpha. So then I take these adjusted alphas and I average them, and so I determined that this source is very non-detect for adjusted alpha, but I'm left with seeing that this source has detectable levels of uranium. The maximum contaminant level for uranium is 0.03, and while this source hasn't exceeded or met or exceeded the MCL for uranium, it's detecting it. So what happened to this source is they're back on once every 3-year sampling for RADs as a whole, but they have a separate uranium sampling requirement, which is now once every 3 years. So that's happened to quite a few sources in the state of Utah over the past few years. Anyway, that's what happens if you go over the MCL. So the rule itself, you can find it on our website, which again is drinkingwater.utah.gov. And the R309200 is where you can see the MCLs. And R309205 is where the source monitoring. So that's where you'll find the information about quarterly, once every 3, 6, or 9 years. So that's the rule reference. Again, if you have questions, please check your monitoring schedule, and of course, contact me, and we will work through any issues that you might have when it comes to your radionuclide sampling. So thanks for attending.